Welcome back to my YouTube channel. In this video, we are going to see about distillation column packed tower. It is a part 2 video. Part 1 is about a tray tower. Please look into it. Before going to the packed distillation column, I need to explain about what is a distillation column. A distillation column is a tube that provides a surface on which condensation and evaporation occurs before the gas enters in the condenser in order to contact the more vital liquid in a first fractionation and less vital component in a layer fractionation. Now, this point tells about a liquid when it's entered to the distillation column before the condensation and evaporation can occur before it goes to the condenser. So it explains about where feed is introduced at the middle. It goes to the tray by tray and settles down at the bottom, and it goes to the reboiler, and it again sending back to the bottom of the vessel. So it helps to increase the vapor rate. So you can see that a red point which shows up, it shows the vapor rises up and it goes to at the top, where at top it goes to the outlet of vapor, and it's sent to the condenser or condenser which placed in the outside of a vessel. So condenser that converts a liquid to a vapor to a liquid and send it to a reflex drum. Reflex drum is hold up the liquid, and again it's sent it to the distillation product, and the remaining liquid will send it to the recycling process, which will send it to the top distributed layers. Again, it's a recycling process. It's again works as same. A liquid goes down, vapor goes up, and it converts a vapor to a liquid in a condenser. Again, that liquid will be sent to the product outlet. Again, the remaining product will send it to the top of a liquid distributor, and bottom we can collect bottoms in bottom is called it as a concentrated liquid, will send it to the concentrated receiver. So these are the explanations about a distillation column. Let us see the packed distillation column. Packing provides a large surface area for a vapor liquid contact, which increase the column's efficiency, such as packing or used in the separation of vapor liquid mixture, often used in a solvent. This cell tells about it covers a large surface area as we compare to the tray column. So let us look at parts of a packed tray column, which we have a vapor outlet at top, and we have a demoisture pad, and we have a liquid distributor top, and below that we have a structured packing, and we have a chimney tray, and we have a bottom liquid distributor, and we have a steam beam and a random packing and bubble cap tray as at the top, at the bottom. So next, let us look what are the types of packed distillation column. When we come to types of packings, we have two types of packing. One is a random packing, another one is a structured packing. A random packing which placed randomly at the bottom of the vessel, and the structured packing, it has a honeycomb like a structure which has uniform structure, which covers the more surface area as we compare to a random packing, which placed at the top of the vessel. You can see that image. First image is a structured packing, and second image is a random packing. Random packing. Random packing tower are constructed using a variety of metals and non-metals such as steel, ceramic, plastic, etc. These materials provide the surface area needed for the distillation process. When it comes to the packing, where vapor and liquid comes in a contact for a mass and a heat transfer. When a random packing has been moved on since the earliest day of a commercial packing, it is initially and extremely a non-uniform packings, such as it has three generation of packings. First generation was morely ununiform, consists of cylindrical shape, such as a ring, and the second generation has been introduced in 1916, moved to enhance the amount of surface area per volume of a packing by including a slots, hole, and a fingers. Typically, a second generation packing has like a sandals and a ball rings. A third generation proprietary random packing has been in the market for several long years, have a high opening area with a complex surface in an attempt to maximize the vapor liquid contact and minimize the pressure drop. On the bottom of the image, we can see that the through flow and around flow. This is how the flow has been acted to the random packing, which is randomly placed in the column, in a distillation column. And this is how a random packing has been worked in a distillation column. Next, we come to a structured packing tower. Compared to a random packing, a structured packing tower offers a more surface area and have a low pressure drop. When it compared to a random packing, it's actually randomly placed. Structured packing, it has a uniform structure of placed in a distillation column. Structured packing can be manufactured from a kerosenic sheets and perforated embossed metal, plastic, etc. This point is stated about it has made of a kerosenic sheets, which is manufactures and designs output looks like a honeycomb structure with a vertical flow, and it gives a high surface area with a low resistance to the flow. The surface has been close to the maximize the liquid separating. It shows with a low pressure and a low flow rate per cross-sectional area of a column. Usually when a liquid passes through the structured packing, the flow has been less. It's because of liquid has been separated through the structured packing. Definitely when it was separated of liquid, definitely a pressure and flow will be lesser as we compare to a tray column. Now, as I said earlier, when it compared to a random packing and structured packing has a uniform of packing. It has a specific structure. When it comes to a random, it has been randomly placed. That's why it's called as a random packing. That's why it's called as a structural packing. So let us see the difference between a packed and tray columns. Packed as a low capacity operation. In case when it comes to the tray column, it can handle a wide range of applications. A continuous contact. Packed column has a continuous contact, but in tray it has a stage by stage layer of contact. As we seen in a previous video, it has a stage by stage layer. It has a low liquid holdup. A packed column has a low liquid holdup. When it comes to the tray column, it has a high liquid holdup. As I know before, the packed column has a less pressure drop. When it comes to the tray, it has a high pressure drop. Packed column is more economical, and tray column it is a high cost of a material. When it comes to the cost wise, packed column has more advantage. Little more advantage. When usually the packings have been made up of a plastic or metal or ceramic, which is easily removable and which gives a longer life. When it comes to the tray column, it's mainly made up of steel, stainless steel and carbon steel, which more costly and cost of material high too. And as well as everyone knows, packed tower has a more surface of mass transfer, and it comes to the tray column less surface area of mass transfer. It's this due to the packed column has been fully covered in a internal of a vessel, which has a structured packing and both random packing as well. But when it comes to the tray, it has between gap to flow for the liquid. When it comes to the kerosene as liquid, it is a good packed tower as a good kerosene liquid holder. It's due to it's made up of steel and ceramic. But when it comes to the tray, we need to be expensive for the material for a kerosene as liquid. No, we need to be. It's more expensive for the material to buy. To spend. You need to spend a lot of money for the tray column as well. You may ask a question compared to packed and tray, which is widely used for the distillation column. As I know, tray column has been widely used for the distillation column. compared to the packed. It's because it handles wide range. Output will be faster as we compared to the packed column. No, our flow will be a bit faster when we compare to the packed column. That's why the tray column widely used for the distillation column process. And that's all about a packed tower column. And thanks for watching this. Do check my part one video as well. Thank you.